practical experience in training, consultancy, and research. Her current research is machine learning. She is a Google Award of 110,000 US dollars in 2010 while she was pursuing her PhD research. She is a member of ISACA and ISACA Kampala chapter, a board member of MicroPay, the president for governance and finance for the Association of African Development Learning Centers, which is an affiliation of the Global Development Learning Network, which is coordinated by the World Bank. Dr. Jennifer, I welcome you to this session. Our second panelist is Mr. Alex Motil. He's a lecturer at Makerere University with he has master's degree in computer science, Bachelor of Science in computer science, and prior to joining Makerere, he has worked in various organizations, which include academia, research, and industry, and he specializes in privacy, that is private cloud services, identity federations, and promotion of use of open resources. I take this opportunity to welcome both Mr. Alex Motil and Dr. Jennifer Aduo to this presentation. Mr. Alex Motil, take the first front chair, and then later I will call upon Dr. Jennifer to proceed. Kindly make sure that you don't use more than 10 minutes.
Thank you very much, Nicholas, and the rest of the panelists this afternoon. To the online community, we want to again welcome you and hope that, of course, this will be refreshing and we shall be able to benefit from our presentations today. Thank you. So today I'm going to be talking more about formation and of course the fourth industrial revolution. We'll just share this. Yeah, so our session today is about how we can be able to make university curriculum relevant to digital transformation and the fourth industrial revolution. So for my part, I'm going to first of all introduce you to digital transformation and the fourth industrial revolution. But first, digital transformation. Digital transformation really brings two terms together. One digital and the other one is transformation. And when we talk about digital, we basically talking about computerization. And then when we talk about transformation, of course, we are looking at a change, could be a change in how we, for example, run processes. And so when you combine these two terms, we get digital transformation. And this means that we are creating new or even modifying existing business processes. We could be also dealing with business models. We could be dealing with business domains. We could be dealing with culture or organizations. And the main aim of all these is because we want to be able to adapt to the changing business and market requirements. Now, there is a term that is usually termed as FOMO, and FOMO says the fear of missing out. We know we're living in an era where digitization is actually fast-paced, and for us to benefit from this, we have to change the ways in which we have to change. Of course, even to the level of the lives that we live in, they are all going to be affected. I would say that digital transformation is the reimagining of business in the digital age. And so many disciplines, of course, are affected. When we talk about digital transformation, we are looking beyond just the change in the business environment, but also how we can be able to apply technology to solve problems that affect us as communities. And so digital transformation is actually very important. We also might want to become competitively advantaged in this environment. And so we are saying with digitization, we always have to be able to ensure that we are moving in the direction or towards the direction that technology is driving us. And this involves the use of so many other integrated tools of technology. It could be methods, for example. And these tools include, for example, social media, cloud computing, remote access and mobility. Now we know we're working in an environment where we don't need to be physically around. Today, I think all of us, the presenters, are not in one room because of just the ability to work remotely and be mobile. Big data, there's a lot of data that is being generated. IoT, we are living in a world that is connected. Artificial intelligence, now newer machines are going to be performing to the level of humans. And so these are the different technologies we are talking about, and we know they are taking us into the new era of technology, and we should be able to, of course, embrace it. Now comes the term fourth industrial revolution. Now here we are talking about automation. We are talking about an era where billions of devices are being connected. And with this connection raises problems on how, for example, communication should happen between these elements. And it's all about what we are trying to deliver. And in terms of course, the societies that we live in that are already adapting these technologies, we always have to look at ways in which our processes, for example, can be like automated. Now, we talk about machine-to-machine communication, IoT, again, similar technologies to what we have in digitization, how we can be able to, for example, monitor, say, processing plants, and then can we be able to build machines that can, for example, help in diagnosing issues without, of course, the need for human intervention. Now, we should also note that these technological advancements are rapid. Okay, they are coming really at a higher speed than we anticipated or expected. They are disruptive. Why? Because they are changing the status quo, and then they are pervasive, meaning that computing now is in almost every device. It's not like saying we have a big server that is just doing the computing for us. Almost all devices, electronic devices that are being manufactured now have some power of processing. And so to capitalize on the fourth industrial revolution, digital transformation is key. What are we saying here? We move from digital transformation, and when we apply all these digital technologies, then we know that, of course, we are getting onto the fourth industrial revolution. The history for this, we've talked about so many revolutions, right from 1.0, now we're talking about 4.0, and we never know, maybe in the next 100 years, we'll be talking about 5.0. And just to summarize this, in terms of how we've come to the fourth industrial revolution, back then in the year 1784, we were talking about how mechanization was actually helping sectors such as agriculture and production industries to improve on, of course, the delivery of some of the products that they were working on. Industry 2.0 looks at introduction of electrical systems. Again, we are just trying to find out how we might be, or we should be, more efficient and effective at every level of this industrial revolution. And then on the third revolution, computerization, the fourth industrial revolution, we're looking at connectivity and how we can be able to harness that connectivity, of course, again, to ensure that we're able to perform better, to change how we live, how we work, and how we collaborate. Now, these technologies are many. The fourth industrial revolution technologies are many, and I know that maybe you've heard about some, maybe you've also encountered some. But according to this report by Deloitte, that was early this year, on the intersection of readiness and responsibility, these are the main technologies that were found to have the most impact on many organizations. The first one being the Internet of Things, followed by artificial intelligence, to cloud infrastructure, to edge computing. And so when we want to acquaint ourselves with the terms in the post-industrial revolution, it's very paramount that, of course, we understand some of these technologies, if not all. And then also in this research done by Salesforce, and here the hiring managers were asked would technology would change the way we work within, say, the next 5 years. Again, the big data processing and analysis came first, followed by artificial intelligence and the Internet of Things. In Africa, again, according to the report by the Africa Development Bank 2019 on the stakeholder assessment of Africa's readiness for technologies in the fourth industrial revolution, you can see we are talking about ranges of 30, maybe 1% to 35% in terms of artificial intelligence and their readiness. Some of them are very ready, 35%, some are ready, 35%, 31% that are not ready. So you can clearly see that, yes, even in Africa, we can't forget to, of course, talk about the fourth industrial revolution. In Uganda, we look at the sectors that we, of course, feel can be impacted by this revolution, and some of the technologies that we know are already in place. And here we've summarized some of them. The sectors include agriculture, energy, regional integration, industrialization, and well-being. Well, we'll catch up definitely at some point. And the technologies, AI, big data analytics, blockchain, 3D printing, not so much. IoT, really catching up. And then, of course, the use of devices such as drones. Now, just to take you back to, of course, the issue of Africa and Uganda specifically. Yes, we know that there are already definitely some efforts, but there are questions definitely on, say, how can we be prepared, or how can we be much better prepared to, of course, tackle some of the issues that are going to be brought about by the fourth industrial revolution. We know that, for example, in Uganda, there are technologies which are catching up so fast. When we talk about mobile digital financial solutions, we talk about things such as mobile money, and we know that millions of users actually are using some of these technologies. In AI and blockchain, I think in AI, for example, there've been some works, innovative works on how we can be able to, for example, do diagnosis of diseases. In agriculture, we've had cases where, for example, where the information can easily be disseminated, actually, even by the press of a button or a few more buttons. I will hand over to Dr. Aduo. Thank you.
Thank you so much, Mr. Alex, for that insightful presentation about digital transformation and the fourth industrial revolution. I now take this opportunity to welcome your co-panelist, and that is none other than Dr. Jennifer Aduo. You're welcome, Doctor.
Okay, thank you so much, Alex. Let me just share my screen. Let me just share my screen. Give me a minute to share my screen. Share screen, just give me a minute. Where am I going? Just a minute. Sorry. Just give me a minute to get it right.
Okay, we're waiting for you, Doctor.
Okay, okay. This one. Hey, where did I go? Alex, can you just project for me? I'm just getting a few. Hello.
Yes,
Yes,
yes.
yeah. Yeah, it's there.
Okay.
Okay. Good afternoon, Nicholas. Good afternoon, everybody online audience. Thank you very much once again for giving me the chance to be part of this international conference. I really appreciate. And thank you, Alex, for basically introducing us to the fourth IR and of course digital transformation. I'm going to talk about the curriculum. We are saying that basically curriculum is just basically a plan that guides the lecturer and the student in basically teaching and learning, where we look at the competencies, we look at the learning outcome, we look at the content to be covered, we look at the training methods, and of course, the resources that we shall use in the training, and lastly, assessment. These are very important in curriculum design. And basically, the three types of curriculum design. One of them is subject-centered, looking at basically is common among the lower levels of education, like in primary school, maybe subject design on maths, on physics. And then we have the learner-centered type of curriculum design, whereby above the content, we have lots of learner activities that can encourage the learner take his or her time to get the contents right. The last one is called problem-centered design, and this is very important, especially for university curriculum. I note that these days, when we submit our curriculum to National Council for Education, they normally check on this type of curriculum design. Why? Because we've realized that for our students to maybe like be more marketable when they get out of university, they must have problem-based skills to solve real-world problems. And I do recommend that for university curriculum, we should focus more on problem-centered curriculum design. We note that under the IEEE framework for computing, they basically highlight 6 areas which are very important for IT domains. One of them is mobile applications, which when you look at the current era is the in thing. Social platforms, user experiences, especially Internet of Things, big data, and of course, cyber security and automation. When we talk about digital transformation and 4IR, these are the critical things that we need, maybe like when we think about curriculum design, looking at our current graduates, they must have these core competencies, they must have these core skills in the grips of their hands, so that we have graduates who are more marketable, not only in Uganda, beyond our nation. And that's what we're actually all advocating for. I did review the curriculum of IT at the undergraduate level, the one for computer science, and then the one for information systems. And I realized that most of the current curriculum that actually is being offered by universities, especially in Uganda and maybe East Africa, they do not capture the issues of artificial intelligence, which we realize is a very core key for digital transformation and of course the fourth industrial revolution. They miss out things like big data, which is very important. They miss out things of Internet of Things, knowing well that when we talk about the fourth industrial revolution, we're talking about automation, and automation requires artificial intelligence, requires big data, requires Internet of Things, meaning that if you're to like come up with if we're to have graduates who can develop systems which are intelligent, meaning that artificial intelligence must be taught at the university level, especially for those computer science, for information technology, and even information system programs. We must incorporate those aspects into our curriculum. We note that the fourth IR is talking about having connections between the virtual and of course the physical assets, and meaning that our graduates must be very competent in understanding these technologies so that they're able to come out like with systems that can support not only our nation, but of course beyond the nation. We should look at having graduates that are not only for the Ugandan market. Once we give them the skills, they should have skills beyond the global skills that are needed globally, so that we maybe deal with the issue of like unemployment, especially in the Ugandan context. We looked at, next slide, please, the next slide. We looked at, in terms of curriculum development, it's actually a requirement by the regulator that before you come up with any curriculum at any level, you must involve the students. And normally, the case of Uganda Management Institute, what we do normally, we normally call a stakeholders workshop, where we involve the students of the current program and the ones maybe like who have completed that course, so that they can give us their input in the program justification, its rationale, whether it's still relevant, the aim of the program. We look at the learning outcomes, whereby these students actually give us comment, give us input into the content, into the mode of delivery, the teaching methods, and the mode of assessment, reading materials. Even in terms of the lecturers, it's a requirement by a National Council Federation that whatever content you provide before it's approved by the regulator, you must have evidence of like having a stakeholders workshop, whereby the students maybe of that program or maybe the previous students have had input, and what they require is that you provide evidence of the minutes of that stakeholders workshop to the regulator before they can actually approve your curriculum. So I think this is very pertinent, so that like when we improve, like when we include the aspects of the 4IR digital transformation into the curriculum, we believe that we shall have the right content for our graduates. We looked at, we reviewed the curriculum, as I mentioned earlier, for IT, for computer science, and then for information systems. And we realized that most of the curriculum currently being actually conducted do not capture the issues of the fourth industrial revolution and of course digital transformation, which are very pertinent to our nation and to the world at large. For instance, we are proposing that big data aspect should be captured into the curriculum, looking at things like big data analytics, which is very important, data science, which I believe, I may be corrected, I don't think any university in Uganda is actually having maybe any degree or any training on data science, which is a very important aspect of the fourth industrial revolution, and of course to be able to fulfill the digital transformation. Things like data warehousing, I think this has some, maybe some universities have it, but I think not all. Data visualization, data mining, and of course machine learning. Now, machine learning is very, very important. For instance, when we talk about developing automation, you must, automation means that having systems that have a bit of intelligence, you cannot miss out machine learning. Machine learning is very important, and I believe that universities need to like take this seriously, to include a content on machine learning on their computer science or IT curriculum, so that at least we have graduates that can have that skill. I can share a bit of experience that when I was doing my PhD research about machine learning, it was quite a challenge because that time Makerere University, where I did the course, did not have any training on machine learning. But of course, I had to go ahead and basically try to read on my own and go ahead and research and be able to come up with an output out of machine learning. It's a very, very interesting field. Now, looking at artificial intelligence, I mentioned that automation, having intelligent systems need artificial intelligence. And of course, artificial intelligence depends on machine learning techniques that things like decision trees, k-nearest neighbor, artificial neural networks that actually you have to use to make these machines intelligent. So we are proposing that for computer science and IT graduates, the content that should be added is like machine learning, some bit of actually programming, which I didn't put here. Programming is very important, a bit of statistics, robot hardware, and control and software skills. For instance, you cannot develop a robot without having a bit of machine learning. There's what we call reinforcement learning. It's like what they use for developing robots. The other thing is in the context of IoT, we are saying that the world is getting more connected, human beings to machines, to all these things, as my colleague explained, and meaning that our graduates, if they'd like to be better IT support system for these organizations, the universities must include in their content things like sensor technology, cloud management, cyber security, big data management, integrating smart technology, especially involving IoT, which from Alex's presentation actually is already taking place in Uganda. But the question is that do we have IT graduates, maybe computer science graduates who can support that technology? Do we have IT graduates or CS graduates in Uganda or beyond, which can maybe support our local industry and beyond? Now, at the US National Academics Science Data Forum, they came up with a proposal that for us to like be able to like implement, maybe like be part of the 4IR revolution, we need to have some basic concepts like our curriculum must have basic concepts like basic computer concepts, computing for the physical world, and of course the cyber world, discrete and continuous maths, cross-cutting application, modeling, and of course heterogeneous dynamic systems. And then they're talking about cyber physical systems. We need to like understand how to develop them. Other than, especially I believe maybe some of us have gone to the information system class. We know those how we develop information system, but I think we need to go beyond that and look at train our graduates that how do we develop cyber physical systems, which is the in thing today, so that our graduates, I believe, once they have the skills, they will be marketable beyond Uganda. And of course, the issue of, I think, unemployment would be addressed once those skills are actually included in the university curriculum, so that we get graduates who are competent in the digital transformation and, of course, the fourth industrial revolution aspects. Looking at the 21st century skills that employers expect from university graduates, the sources from that source, but I believe that under the learning skills, I think one of the learning skills that we could actually include is like problem solving skills. We know that most times we have graduates who are not very practical because while training them, we do not give them maybe like projects which could actually build up their practical their problem solving skills, so they're able like to solve the real world issues. For instance, I was looking at skills like there's been this talk about like COVID testing up for the Ugandan, in the Ugandan context. And I was wondering that where the computer scientists, where the IT professionals can actually come up with a COVID tracking app at the Ugandan context. Now, there's what they call the literacy skills. I do appreciate what has been highlighted. However, there is need also like for us, the students, the Ugandans, to get what they call digital media skills. Now, what do I mean here? Now, those are the skills that will enable anybody to be able to use the digital media skill, like you can be able to apply it, analyze it, use it, and of course, use those digital skills that Alex talked about to create new knowledge for the betterment of our society. Now, I would want to add that under the life skills, I think they're talking about lifelong learning should be a skill, that in this era of the fourth IR and of course digital transformation, there's so much that we need to keep learning, and the lifelong learning is actually one of the life skills that everybody should embrace if you're to be relevant in the fourth industrial revolution, and of course taking into context of the digital transformation. So I was talking about that the learning skills, we could talk about problem solving skills should be part of that list. And then we're talking about the digital literacy skills is very important. Now talk about digital transformation. So that digital literacy skills, looking at the IR, the 4 IR technologies is very important. And then the last one I talked about having lifelong learning skills, lifelong learning. That's one of the skills that actually people are talking about in this era of the fourth industrial revolution.
Thank you, Doctor. Please try to wrap up.
Okay, yeah. Just the next slide. The last one, please. Now, we are concluding that we want to talk to our regulator, that is National Council for Education, that they should actually allow the inclusion of 4 IR competencies in the curriculum for computer science, for IT, and for IS, and that universities should actually train their lecturers in the 4 IR competencies. And then we're talking about maybe like having students or PhD, people like undertaking their PhD, like to have research, participant research on AI, IoT, and of big data. Then of course, Uganda should focus, of course, preparing graduates to be able to be relevant for the fourth industrial revolution, and of course, digital transformation. As already mentioned, that universities maybe could like add on all their programs some elements of the 4 IR, looking at artificial intelligence, IoT, big data, so that at least there is understanding of all these concepts in all the programs, and of course in all the graduates who leave universities. And then of course we are saying that for us to do it alone, I think we need to collaborate like with those institutions that have had these things working. I mean, talking about public-private partnerships, and of course working with those who have done it before, so as to be able to like build our competencies in the fourth industrial revolution. Of course, maybe like in curriculum design, how do we incorporate them in our university curriculum? Thank you, moderator, and thank you, participants, for listening.
Thank you so much, Dr. Jennifer, for that sharing and the area of curriculum and the skills that we need to succeed during the 21st century. You've been in academia for some time, and we respect your views. And you hinted a lot on issues to do with students getting ready for the job market, especially Uganda and Africa at large. And you mentioned something like students will get out when they're unable to support the systems which are outside there. And as you well know, many of the universities usually begin their active practical sessions, especially in projects later in their years of studies. So for example, if I like in IT, someone is beginning to do projects in third year, and yet we are saying that the change is occurring fast. The revolution is not even settling at 4. It might come to 5 in the nearby future. So when do we need to change and we focus on those projects? What do you recommend to other academicians outside there?
Okay, thank you very much, Nicholas, for that very insightful question. What I recommend is that, based on the guideline for our regulator, you must have documented that content into the curriculum. Of course, I do take note that most of the curriculum, I think the projects are done later, which I think is the wrong thing. I believe that university curriculum to ensure that there's more practical bit of it should be per course unit, so that like when you finish a course, maybe normally like for our case, we have basically 12 courses, like for each course unit, somebody must be given a practical project before you wait for the end of the 3 years to do the project. And then also like to really incorporate skills into these students. We are saying that actually I'm proposing that the 3-year internship, which is so done at the end, is actually a wrong thing. Now, internship actually should, like what is done in Singapore, what's done in Germany, like even in the US, they're saying that students, as they study this program, like IT, should be attached to an industry, to maybe a campus, so like they get the practical skills while on the case actually from first year. But looking at the current context, it's a different story, as Nicholas, you have mentioned. They wait for the 3rd year. That's when you do a project. And of course, what we realized that most of the projects that these students actually do, they don't even do it themselves. Why? Because maybe they can engage, they call it the mercenaries to do it for them, which I think is fitting the issue of practical skills that are needed for the 4IR revolution. So my issue is that can we bring the project bit or the project bit in the beginning of the program? And can we have the internship, other than doing it in the last year of the course, can we have it at the beginning so that these students are actually attached to companies so that they learn while reading, to be like to get the practical bit, to basically to attain those skills at the beginning of the course. For instance, but maybe I'm just being reminded that, but even beyond that, maybe what you can do is like what Singapore is doing actually. They have what they call skills future, whereby they look at all the university graduates who have no content, not covered any content of 4IR. What they do, they actually, this an institution that is actually focusing on training of the 4IR and of course DT competencies, which we do not have in Uganda. Maybe NITA could actually pick up that. I don't know, with the funds availability, looking at the needs, the global needs.
Thank you
I
so
hope you
much.
have tried to address your question.
Yes, thanks so much. In fact, towards the end, you raised an important item of establishing those innovation villages, something like that. And I think recently in some of the universities in Uganda, they have started that, and possibly they are not yet there. And at Isaka, that's why this topic was chosen, and wanted to engage you to understand what you're doing so that we can advise. And I would maybe recommend that, doctor, next time, maybe when you're considering reviewing programs at your university, and maybe when you are supporting National Council, try to engage Isaka Kampala chapter, and I'm sure they will be able to advise. Back to Alex. Alex?
Yes, 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 Nicholas.
Okay, yes. When I heard of the fourth industrial revolution at first, what came to my mind was like I made an assumption of seeing like someone flying in space, teleportation, that is, and possibly many of the young students who are listening into us could be thinking in that line. We talked about OIT, we talked about big data. Possibly they are not understanding what we are talking about. Most of those who are maybe in early years, like first years, or those who are getting there just right now. What do you need, summarize for them so that they are able to understand the context that we are talking about?
Yes, so just going back to, I think, my final slides, we talked about the fourth industrial revolution as living in an era that is connected. And with connectivity comes, of course, some challenges, but then also there are some opportunities. When we talk about, for example, IoT, we are meaning a situation where devices are able to, for example, generate data. Take an example of maybe a company that is selling certain products, and they want some feedback, for example, on these products. And so these products can actually be embedded with sensor devices, and these sensor devices are able to report, for example, the usage. And then when you have like millions of these devices, that means that you are going to generate a lot of data. Now, to analyze that data, you now need to bring in the big data analytics. Okay, so we're moving from IoT, then we are getting into big data. Okay, and then as we analyze this data, we might generate some very interesting, of course, reports. Okay, and that might mean that, of course, we need to, for example, improve the modes of delivery of our products. Maybe there are certain components of our products that need major revisions. Okay, now when we bring in AI, again, Dr. Duo has highlighted on this, that in AI, we are looking at the possibility of humans, for example, being able to be equated to machines. So machines being able to perform, for example, what we're doing. Right now we go to class and teach, but you never know, maybe 100 years from now, there is a robot called Mr. Alex that is actually conducting a session, because basically it's able to understand the environment that it's operating in, able to understand the people that it's delivering to. And so there is that change when you bring in artificial intelligence. Things like maybe, she talked about machine learning, maybe vision, computer vision, being able to actually use images and generate also some very interesting information. Now, we should note that, of course, think capabilities of humans are also limited. And if we don't use machines, for example, to do some of this analysis, then we are definitely at a disadvantage. Yeah, so that's really a brief on some of the key technologies in the fourth industrial revolution. And those are the ones that we see actually are here, and we should really be prepared.
Thank you so much, Mr. Alex, for you sharing. And I'm going to ask one general question as we come to the conclusion of our session. And this goes, we've all admitted that the IT is evolving very fast. The digital transformation is happening more than the way we think. The fourth industrial revolution is not settled. And again, then we identified that there are some loopholes in the existing curriculums. And then we need to advise students who are in the audience right now to bridge the gap. What are those recommendations that you would make to particularly students at an individual level to make sure that they prepare themselves for this fourth industrial revolution, for the digital transformation, amidst the challenges which exist in the current curriculums? I begin with you, Alex. I will end with Dr. Jennifer.
Okay, thank you again, Nicholas. So as a student, I think it's very important to note that if, for example, you went to do a course to be maybe a systems administrator 3 or 4 years later, by the time you graduate, that position, for example, may not be there because it's actually been displaced. There is probably so many software-defined applications that are doing what exactly, of course, you are doing. But again, we should note that even with displacement of, say, positions, there are definitely opportunities. There are many opportunities. I mean, we talk about, say, data scientists. We need them, but they're actually not there. Application developers, we now need people that are going to write applications that to support some of the technologies in the fourth industrial revolution. But probably our curriculum, like again, it's been presented, is not preparing us so much for it. And so as a student, you really need to be involved. You need to research, for example, about these technologies. You need to improve on, say, the problem solving skills, because that is actually a very important skill when you go out there. Maybe just an example. In one of the curriculums that we're reviewing, we were looking at some aspects of emerging technologies. So what we define, we come up with an area, and then for that particular area, you basically use technologies that are appropriate at that very point. Okay, so we try to leave some space, knowing that technology keeps changing. And at that point, you should be able to actually adopt what is, of course, trending at that particular instance. And then the opportunities maybe to be involved in some of these innovation calls, because I'm sure most of them are actually trying to address some of the local challenges that we have, but trying to use some of the technologies that are in the fourth industrial revolution. The other one also, maybe register with some of the professional, or do some professional certification. In line with this, it will enrich, of course, your class skills, but also that should prepare you in a way. And do projects. Projects are really very important, because in a way they open up your mind actually beyond the classroom. Yes.
Thank you, Alex. So it's a turn for Doctor.
Okay, thank you, Nicholas, for the moderation. My advice is to the people out there, especially these young graduates, that do not give up. There are a lot of online courses available. For instance, if I was actually, I still look for them. Look for a course on Internet of Things. There's so many short courses under that sort of MOOCs, MOOCs, massive open online courses. There's so many of them, Coursera. Please, the world, you look at from Alex's presentation, they want people like with data scientists are needed globally. People like who understand machine learning. I mean, the cybersecurity experts, people are looking for them globally. So go online. Those programs are free. Register and do them so that you are marketable globally. I always tell students that I interact with, that tell the young people that please do not limit yourself to Uganda. There's a lot of internet, there's a lot of content out there. There are a lot of free courses online that one can do and get the required global skills on IoT, digital transformation, big data analytics, business intelligence, machine learning, artificial intelligence. There's a lot of content. And of course, ISACA is our past partner on those security courses. Please do those courses and you'll be looked for globally. I can give my case. For my case, like when I went for my PhD, there was no course on machine learning, but I just had to go back to read, talk about lifelong learning. So I had to go back to the basics, back to the book, back to reading to get the skills. So I encourage the people out there. Let's not look about the challenges in our country. Let's look about, I don't have money, but there are a lot of free online courses. So let's get back and read so that get the skills on the 4 IRA skills, IoT, what Alex has presented about. Let us go out, get those skills, and we shall be marketable. There's a course, I think, by GSMA UK that offers courses like all those technologies, and they're free. So please go back and do those courses and make yourself relevant for the 4 IRA and of course for digital transformation. The sky's the limit for IT. Like normally, I normally go for a lot of conferences, and you find there's a gap. There's a gap of there's a gap actually globally. So I believe, especially like this cyber security issues, cloud computing raises those security challenges. Let us do the courses, and I believe ISACA is our partner, and they have courses that we can actually build on to make us global experts, so that we don't go for those cheap jobs like in Abu Dhabi, low scale, low jobs. Let's go for the high jobs in the USA, in Germany, in the UK, because they're there for data scientists, for IoT experts and etc. Those are my comments.
Thank you so much, Dr. Jennifer. Indeed, you've spoken. Mr. Alex has wrapped up. And then you've made us to think and believe that students are co-partners in the development of our curriculums. And therefore, we conclude by imploring universities and other academic institutions that are not engaging maybe their students or alumni to make sure that they engage them so that they improve on their curriculums. Doctor and Alex, please, as the doctor mentioned, ISACA is the partner to everyone as long as you want to excel within your specialization, especially those specializations that relate to information technology. We've come to the end of our session. We call it a day. I appreciate you so much.
Thank you,
Thank you.
and a good day too.
Thank you. Thank you. Thank you.